So this question, they want us to solve this inequality. Teachers teach it different ways. The method I like to do is I like to just graph this on a Cartesian plane or a two-dimensional graph, an XY plane, and then analyze it from there. So the first step is to put it in standard form. So let's move the 6x over. So it's minus 6x plus 9 is less than or equal to 0. And now I'm going to graph this right here. To graph that, well, before I graph it, let's first see if I can factor it. Does it factor? It looks like it might factor like this. 2x minus 3, 2x minus 3. See how that's a perfect square and that's a perfect square? And if I add, oh no, that didn't work. That would have had to been a 12 right there, not a negative 6. So it actually looks like it probably doesn't factor. So instead, what you can do is you can see what the solutions are for it. Basically what I'm trying to do is I'm trying to graph this inequality and then find out when that inequality is less than 0. So as a visual, if that inequality looks like this, if that parabola looks like that, when is that value less than 0? Well, here's 0. That's where it's equal to 0. So it would be less than 0 anywhere in here. Mm-hmm. So your answer would be, if that was the case, your answer would be between whatever this point is right here and that point, let's say 0 and 5. It'd be x is between 0 and 5 inclusive. That's what you're going for, right? Yeah. So the first step is to graph that inequality. Let's see what that inequality looks like. Well, to graph this inequality, there's a couple ways you can do it. Probably the easiest way to do it is to find the x coordinate of the vertex, which is, remember, negative b over 2a. Mm-hmm. If you could factor it right away, that would be the easiest way, because you could find the two zeros, and those are really the most important thing. Yeah. But if I do that first, it's going to give me a little bit of a visual of what I'm looking at. So that's 6 over 8 or 3 over 4. Mm. So that's the x coordinate of the vertex, and the y coordinate of the vertex, if I plug it in, is going to give me so the y coordinate of the vertex is going to be equal to 4 times 3/4 squared minus 6 times 3/4 plus 9. So that equals one of these 4s. This is 3/4 times 3/4. Mm-hmm. So one of those 4s is going to cancel. So you're going to have 9/4, because 3 times 3, and then 9/4 minus 18/4 plus 9. 18/4 minus 9/4 is negative 9/4. I'm just adding those together. Plus 9. Negative 9/4 is what? Negative 2 1/4. Mm-hmm. Plus 9. So that's 3. That's 6 3/4. Yeah. So my vertex is 3/4, 6 3/4. Now, you might think, well, why would you go through all that trouble? That was such a pain in the butt. Well, the reason I did that is because now I can see right away the solution is going to be no solution. Yep. Because right away I can see that my vertex is 3/4 over and 6 3/4 up. It's right there somewhere. And because this is a positive leading coefficient right there, mm-hmm. the graph opens up. And so right away I can see I have no x-intercepts. Which is important, because they're asking me, when is this less than or equal to 0? Well, look at this graph. When is it ever going to be less than or equal to 0? It's never going to be less than or equal to 0. The alternate way you could have done this, though there's lots of ways, but you could have tried to find the x-intercepts by using quadratic formula, negative b, so that's a positive 6, plus or minus, let's see, negative b plus or minus square root of b squared minus 4ac, 36 minus 4 times 9 all over 2a. And when you do that, you'll notice right away that that number is bigger than 36, and so you have a negative number inside here, which means you have no x-intercepts. Okay. And if you have no x-intercepts, you're still not done. Because you could have had no x-intercepts, but the graph was opening down like this, right? And if that was the case, then your answer would be all real numbers, right? But we actually have no x-intercepts, and we know that the graph is opening up because it's a positive leading coefficient, which means the vertex must be above the x-axis. So that takes some thought process as well.
Wait, so could I just